What's up, good people? Welcome back. Okay, this is Trockers. We have a problem on modulus graphs and inequalities. It's from November 2016. We are given the function f of x is equal to 2 minus absolute value of x plus 3, 1. We need to sketch the graph of absolute of f of x. And hence, use your sketch from item 1 to solve the inequality f absolute value of f of x or modulus of f of x is greater than 1, right? So guys, one thing that we need to understand is to identify our parent function. So the parent function here, right? So the parent function here is y equal to modulus of x or absolute of x. So you need to know the graph, right? So we know that, okay, the graph of the parent function is V-shaped, right? With the vertex at the origin, so it is 0, 0. So once we do that, you can then perform the transformations. You start from inside, you're going to move 3 to the left, right? When you move 3 to the left here, you reflect over the x-axis and you shift the graph up. Those are the 3 transformations which have taken place there. Okay, so without spending much time, let's go ahead and get started. All right, so I am going to put the function down here. So f of x is equal to 2 minus x plus 3. So guys, when you are graphing this, pay attention to the key points, right? So I'm going to do it in steps, in stages. The first one, let's have our parent function graph. It's at the origin. Then plus 3, we are moving 3 to the left. So when we move 3 to the left, I want us guys to pay attention to the y-intercept and the x. So here the x is good because it's just -3. So the y-intercept when x is 0, so when x is 0, we are saying absolute of 0 plus 3, which is 3. So this point here is what? Is 3. Then if we reflect, so we are going to reflect this over the x-axis. So reflecting this over the x-axis, it's going to be -3 and -3, right? Then we shift that up. So when we shift up here, if we shift this up, it's going to be -3 plus 1, that's -1. So this one here is now +2. Our vertex will be -3 here and 2, and this will be -1, right? It's something of this sort. Okay, so we now have that. So this is the graph of our function. So our function of x is this one, right? But now, according to the question, we need to graph this y equal to absolute of function of x, right? So it's this graph here, meaning to say we are going to reflect all the negatives across the x-axis, right? So our function will be this. This would be the graph that we are looking for, right? So we have our 2 here, right? So we have our 2 there. So it's going to be our vertex. So our vertex is -3, right? Then we have 1 here. So if we draw this, right? I think I need, do I need this? I think I need from here, I also need the intercepts when y is 0, right? Maybe I need these 2 here up there. Okay, we'll see. So what's going to happen here is that the graph is going to be like this, right? Then we touch there and there, right? So it's going to reflect over there and over there, right? So for our graphs, and right, remember this was x, this was -x, right? And here it was x plus 3 and negative of x plus 3, right? So this one here, when we reflect now, this was now negative of x plus 3, and here it's just x plus 3, right? It's just a negative of that. Then when we shift there, this part, which is this part here, it was negative, okay, it was negative of x plus 3 plus 2, right? And this part here, it was x plus 3 plus 2, which is just x plus 5. But remember, this when we reflect the x plus 5 line, we multiply by a negative. So this is now x plus 5. And we do the same here. So this line, I believe it's now x plus 3 minus 2, because we're going to subtract by negative 1, right? Such that our equations, when simplified, we have x plus 5. Here we have negative x minus 3 plus 2. I believe this is negative x minus 3 plus 2 is minus 1. And here we have x plus 1. And here we have negative x minus 5. There is a reason why I'm putting these equations through, right? So for sketching, you don't need, these equations, but just because I need to solve this inequality on the second part, which says absolute of f of x here is greater than 1, right? So when it's greater than 1, right, we are going to draw your line at 1 here, right? So this is greater than 1 at 3.8 here and there. So here it's greater than 1, and here it's greater than 1, and there it's greater than 1. So I need these points, this one, that one, and that one. So when where they interact with y equal to 1, right? So to find the critical points, the good thing is the first one here is 0. So 0 is our critical point. And here we just say it was negative x. So we say negative x minus 1 equal to 1. So negative x equal to 2. So x is equal to negative 2. So I have my negative 2 here. And another one is when we have x plus 5 being equal to 1. So x is negative 4. So we have my negative 4 here. And lastly, when I have negative x minus 5 being equal to 1, right? Negative x minus 1, so negative x is equal to 6, so x equal to negative 6. So I have my negative 6. So to solve that equation where I've shaded there, it means the solution set is x is an element of real numbers such that x is less than negative 6 union negative 4 less than x less than negative 2 union x is greater than 0. So this is the solution set where the absolute value of this function is greater than 1. So guys, as you perform your transformations here, make sure you also label the segments so that you it will be easier for us, especially when we want to solve an equation or an inequality at the end of the day. With that being said, guys, I'm signing out. I'll see you in the next segment. Take care.